Hello, everybody. This is Professor Nagy here, here with the spatial thinking topic for this week. There will be another topic as well, but we'll start with spatial thinking. I have these kind of set up as individual talks, and depending on how long they are, it may be two or three per week. Either way, it'll be posted. You have the opportunity to view or listen to this a couple different ways. The first way is to literally just watch the video and listen to me talk. It is the PowerPoint that's posted to the course Blackboard. Alternately, you could download the PowerPoint and just play this as an audio as we go through. And then as you encounter links or things that you'd like to spend a little bit more time on, you can pause the audio and go look at those things. So we start with spatial thinking, and I specifically start out this way because it really is a different way of thinking. And I'll tell you, it was a bit of a transition for me when I started learning when I think I was 19 or 20 years old. So, gosh, over 20 years ago, in which I had to kind of change the way that I saw things. And I say that because it was about cartography, it was about objects in space, it's some geography, and kind of understanding those dimensions as a way to look at things. Now, technology has changed in our exposure to spatial stuff, things that have a place in space, not space as in outer space, but space as in the coordinate plane that we live on. That technology, as it relates to geography and cartography, are a lot more common these days. So you may have a lot more exposure to the maps and cartography and geography and those kind of visuals more often now than used to be. So spatial thinking, again, is a important topic to start with, to kind of wrap your brain around what kinds of information you are encountering as part of this class. So I'll move on to the next slide here. Come on, there we go. Spatial thinking. And so spatial thinking is thinking that finds meaning in the shape, size, orientation, location, direction, or trajectory of objects, processes, or phenomena, or the relative positions in space of multiple objects, processes, or phenomena. Spatial thinking uses the properties of space as a vehicle for structuring problems, for finding answers, and for expressing solutions. So what this is talking about is that as you are looking at geographic information and geographic representations, all of these spatial elements, these things, these features, these things on our planet, and to a certain extent outer space, but not for our purposes, that we all live in this coordinate plane, and that the things that we see have meaning in context. So if you were to look at a stop sign, for example, that is a spatial element. It has a place upon the planet, and it has, there isn't necessarily a trajectory or direction associated with that because it's not a movable thing, but you can gather or garner the shape, size, orientation, location of stop signs. And stop signs also have a pattern to them. And so it is a phenomena, not necessarily a process, it's an object and a phenomena of stop signs. And so thinking about it in that way, like how do you rotate that? What's behind it? What's in front of it? What's to the left or right, east or west, north or south? Which way are you looking at it in terms of cardinal directions? How big is it? What color is it? All of those things that are associated with that object being placed on land and in space. And so again, starting to think about what we see around us as objects in space and the context of what that looks like, particularly with you as an observer, somebody that's looking at that thing and making sense of it in space. And this also kind of asks you, again, to look at things a little bit differently, to look at things as objects in the world around you. Now, social, political, and economic issues can be examined spatially. They typically have some sort of spatial pattern that's associated with them, but those things aren't objects, right? They're phenomena. And so you can use a GIS or you can use your spatial thinking as a way to extract some meaning of that pattern. And not only that, once you understand the pattern, then you can more easily starts to develop steps for understanding a problem, finding answers to that problem, and for looking at analysis and data, and even just understanding objects in this space for expressing some sort of solution to that thing, whatever it is that you're studying. So I'll move on. Space as a framework. So spatial thinking begins with the ability to use space as a framework. Again, it's an object can be specified relative to the observer, you, to the environment, like literally the land and water and air around us within our atmosphere. Its own intrinsic structure, meaning like what it is what it is. When we were talking about the stop sign, for example, what are the qualities of stop sign in terms of its characteristic, or to other objects in the environment. And each instance requires the adoption of specific spatial frames of reference or context. That means you don't necessarily look at everything the same way. And that has to do with the context. But again, thinking of all these things within this framework of space, stuff that is around us. And so the process of interpretation begins with data, which is generally context-free numbers, text, or symbols. There are characteristics that are associated with the objects and phenomena that we are looking at, whether they are place-based or phenomena like the social, political, and economic issues that we talked about. Information is derived from data by implying some degree of selection, organization, and preparation for a purpose. And in other words, that means that the data are placed into a spatial context. And again, that's just kind of putting some understanding the context as it relates to you and that thing that is in this spatial context. And so the spatial context is critical, it's really important because it is the space the data is in that ultimately determines its interpretation. And so geographic information is a representation of information as we see it as humans, how we're interpreting that information. And again, in today's world of technology, we use technology as a way to provide some clarity around what we understand representations to be. But honestly, we have taken geographic information and we as humans have placed meaning to it. And that is seen through the production of maps and cartography. The three spatial contexts within which we can make the data to information transition include life spaces, physical spaces, and intellectual spaces. And we'll talk more about those things. Moving to the next. So spatial context. Excuse me. In all cases, space provides an interpretive context that gives meaning to the data. It gives us, again, our interpretation of representations. So let's talk about those three things. Life space, the four-dimensional space-time, where spatial thinking is a means of coming to grips with the spatial relations between self and objects in the physical environment. Again, our relationship between us and that stop sign, just going with that example. This is cognition in space and involves thinking about the world in which we live. It's exemplified by navigation and the actions that we perform in space. Navigation, when we talk more about the history of maps and how navigation was one of the initial purposes of cartography, being able to get from point A to point B. Physical space, moving on, is also built into the four-dimensional world of space-time. So we're talking about a space-time continuum. I'm not trying to get metaphysical on you, but that is maybe where you hear or you have had some discussion or thinking about the space-time continuum. But it focuses on a scientific understanding of the nature, structure, and function of phenomena. This is cognition about space, different from life space, where that's cognition in space. It involves thinking about the ways in which the world works. An example might be how an earthquake creates a tsunami. So it's a series of events, and some of the, the beginning of an earthquake is internal, and the tsunami is a resulting activity from that earthquake and the location of where that earthquake occurs. So that's thinking about how the world works. Like, okay, if an earthquake is about to happen, how does an earthquake come to be? You don't necessarily have to spend a lot of time about like earthquake science or anything like that, but understanding that an earthquake can lead to a tsunami as well as other terrible consequences of emergency situations. Moving on to intellectual space. It's in relationship to concepts and objects that are not in and of themselves necessarily spatial. But the nature of the space is defined by the particular problem. And this gets into a little bit more of the social, political, economic phenomena that I mentioned earlier. This is cognition with space, different from about in physical space and different from in of life space. It involves thinking with or through the medium of space in the abstract. That means that, and the example here might be the territorial dispute between two ethnic groups or two territories. Space is in the abstract here for us because do we really know what the where the boundary is between these two groups? Or do these groups actually understand the boundary within their own context? And that's why the argument ensues is, we say in our culture that this boundary was decided, hundreds of years ago or decades ago, and we are pursuing that phenomena. Whereas the other side may say, well, what are you guys talking about? You're crazy. This has been part of our territory for centuries, and you can't just have it. That is an abstract dispute. Although there may actually be a boundary and a physical boundary that these two ethnic groups are referring to, like a finite boundary between the two. But this understanding of that boundary is very much a social and political and typically social, political, and economic altogether, is that phenomena. So that gives you a little bit of, again, spatial context, and we'll continue to talk more about this. Key skills of spatial thinking, there are 5: understanding the context, recognizing spatial schemes, recalling previously observed objects, integrating observation-based learning, and then mental rotating an object and envisioning scenes from different viewpoints. So again, that context and how you see that context with relation to you and objects around you. So let's talk a little bit more about those things. So understanding the context. The significance of context has been noted, but it's important to say that if the data upon which the decisions are based is placed into the wrong spatial context, for example, life space rather than intellectual space, remember we just talked about in, I'm going to go back, in, about, and with, those are those things, it's likely that the analysis will be flawed. So you have to understand the context for you to begin understanding things and following the right path. The next thing is recognizing spatial schemes, which are patterns and shapes. And I think this is one of the key aspects of GIS and cartography. Well, not necessarily cartography. Yes, the cartography is about spaces, and they do give an indication of shapes and patterns. But this idea of patterns, I think, is really important to point out because that is a spatial scheme. If you can see that only lower income people, for example, can only live in a particular place, that is a spatial pattern. And you start to ask questions like, well, why is that? And then you start to understand, or you start to look into the data about that place, about that housing, about the folks that live in that area, but also some other things like, well, why is it that higher end housing isn't in this area? Those aren't necessarily geographic questions, right, or cartographic questions, but you have noticed some sort of pattern, and you can use GIS to provide you with more proof about that pattern, that it does indeed exist, but it doesn't necessarily tell you why. It just shows you that it's there. And so the successful spatial thinker needs to retain an image of the simple figure in mind and look for it by suppressing objects irrelevant to a task at hand. The example of housing, for example, there are things that are relevant to housing that can be access to parks, that can be transportation, that can be schools, that can be access to jobs, how close are you to jobs. But then there's some things that you may not really care about. Like I'm trying to think of one off the top of my head here. In the case of housing, um, we as a something that may not be necessarily a valuable aspect to housing, maybe let's say plant care or plants. Um, Not to say that environmental aspects aren't important to housing, but what are those things that just aren't as important? Is it the color, the color of the paint on the house? That's less important in this case. So being able to identify patterns of significance like cost of housing rather than the color of paint on the house. And so discounting things that are irrelevant helps you stay focused, just like in everyday life planning or doing your assignments. Things that don't go toward the assignment or don't go towards the goals of the course may be less important, but they may be helpful and anecdotal. Um, let's see here, recalling previously observed objects. So the ability to recall an array of objects that was previously seen is called object location memory. You drive through a neighborhood, you saw where things were. Can you recall those things? Do you know what they look like? Do you remember the organization of those things as you were traveling that route, for example? Integrating observation-based learning. So synthesizing separately made observations into an integrated whole. And so let's say you're observing phenomena in different communities. Well, let's say you're on the west side and you're looking at Bay Village, for example. And then you say, you know what, I want to look at communities that are similar to Bay Village. Bay Village is somewhat unique, so maybe that was a bad example, but let's say Lakewood. Lakewood, let's compare Lakewood to the community that's immediately to the east of Cleveland, which is East Cleveland. So you have observations from Lakewood, you have observations from East Cleveland, but take those separate observations from those places and kind of bring it together, like those big ticket issues that we may be looking at, like infrastructure, housing, transportation. I use a lot of planning examples, and I'm sorry, I'm a planner by heart. So, but it's also the physical objects that I'm focused on as well. But so understanding like, okay, communities should have A, B, and C. Let's look at and analyze whether Lakewood and East Cleveland both have these A's, B's, and C's. That's part of the integrated whole that I'm communicating here. The expert analyst moves through the data, gathering information from separately observed objects and views, and integrates this information into a coherent mental image of the area. And so if we think of Greater Cleveland, for example, so those are separate communities, but we're all part of Greater Cleveland in those communities. And so the context of Greater Cleveland or Northeast Ohio, I prefer Greater Cleveland and Northeast Ohio, but that's just a matter of preference, gives you an idea of the mental image of the area. And then finally, mentally rotating an object and envisioning scenes from different viewpoints. Can you see the same things? Well, let me continue. The ability to imagine and coordinate views from different perspectives has been identified as one of the major instances of projective spatial concepts. So mental rotation ability or perspective taking ability could be relevant to those analysis tasks that involve envisioning what an object, such as a building, would look like if seen from another position. What if you were on top of it? What if you were at ground level? What if you were on the east side or the west side? Which way is the sun shining on that thing? So being able to see, how do you move this thing around to be able to see it from different perspectives, just like maybe a social issue or a non-cartographic issue. Moving on to the next. Cognitive schemes for geospatial analysis. So cognitive, how we think about things. Schemes, those patterns or steps that we follow. Geospatial, meaning some sort of geographic, cartographic, place in space type of analysis, figuring out a problem and finding information about that thing. So these are the different cognitive schemes. We have location, spatial distributions, regions, hierarchies, networks, spatial associations, and surfaces. Location. This includes a descriptor with identity, magnitude, location, and time. An additional cognitive component might be familiarity, how familiar you are with a particular place. These occurrences are often called environmental cues. nodes, landmarks, or reference points. So again, a lot of it is, what you remember in terms of location. What are some of the details about that thing? So if you were thinking about a landmark, for example, that is some sort of cue that you might use yourself as a way to get to somewhere. You might be giving directions to somebody else and say, hey, pay attention to this cue on your way. If you passed it, you've gone too far. So being able to give this description of a location. Next, we have spatial distributions. So distributions have a pattern, a density, and an internal measure of spatial variance, heterogeneity, or dispersion. Occurrences and distributions also have characteristics such as proximity, how close we are, similarity, how closely associated they are. Order, is there a specific series of steps in that order of that spatial distribution? And then dominance, which one dominates as the most important element within that context. Now there is regions, so getting a little bit larger in terms of scale, areas of space in which either single or multiple features occur with specified frequency within uniform regions or over which a single feature dominates. So as we're thinking about these different location spatial distributions, think about regions as a larger space and a larger space in which to think about these things. Then hierarchies. So multiple levels or nested levels of phenomena, including features. So there may be elements within the region or elements within a smaller location that you feel have more importance than anything else. And that's typically associated with what you're interested in, what you're studying, what project you're working on for your employer or school or something like that. But that there is a hierarchy, which things are most important and which things are less important in that particular analysis. Now moving on to networks. So linked features, meaning, and we think of networks in a lot of different ways. There are a lot of different examples. I think of roads as a good example for networks. They are linked features. So roads are a feature. Anything that has a place upon the earth is a feature. Linked features, these streets are linked, cross streets, intersecting streets, overpasses, underpasses, alleys, boulevards. They have characteristics, connectivity, centrality, diameter, and density. Networks can also include physical links like transportation systems, bus systems, the rapid, or non-visual systems. For example, like an organizational network. Let's say like all the nonprofits in Cleveland, for example. They are a network of nonprofits. That's a non-visual system. Even though they have a location, it's a non-visual system because we're just thinking about nonprofit in terms of kind of an abstract description. Then we have spatial associations, and those are associations. Associations include spatial autocorrelation, distance decay, and contiguities. Examples of these associations include interaction frequencies or geographic and areal associations. A good example, and I have a lot of technical terms there. For example, the coincidence of features within specific areas. The example here, squirrels are normally near trees. That's a spatial association. Something has squirrels can move, right? So, but trees don't typically move. So there is that coincidence of features. I mean, you could use birds in this example too. That's a spatial association. So as you're thinking about spatial associations, like if there is an occurrence of something in a particular place, what might be something that uses that occurrence, that participates in that occurrence, things that have some sort of familial relationship. And then finally, surfaces. There are generalizations of discrete phenomena. Discrete means that there is a concrete endpoint, including densities of occurrence, flows over space and through time, as in the spatial diffusion of information or phenomena. Surfaces, there is a boundary to a surface. So water has a surface and it comes to an end somewhere. Land has a surface and it comes to an end at the water point. Not to say that it, and what happens there is it disappears under the water, but that surface ends where that water begins. And so that's an example of a surface. Excuse me. Geospatial reasoning. And so we're going to go through a couple different examples of geospatial reasoning. We have inductive, deductive, and abductive. These are things that you've probably heard or explored in other classes, but again, bringing that into what does that have to do with GIS? And so I'm just going to take a sip of tea here. Inductive reasoning. Moving from the specific case to the general rule suggests many possible outcomes, or it's the range of what might happen in the future. So inductive reasoning, however, lacks a means to distinguish among outcomes. An analyst has no way of knowing whether a solution is correct using inductive reasoning. But on the other hand, we have deductive reasoning. It moves from the general to the specific. And deductive reasoning becomes essential for predictions, and it's based on past perceptions. Certain facts indicate specific outcomes. If, for example, troops are deployed to the border, communications are increased, and leadership is in defensive bunkers, then war may be imminent. That is an assumption by looking at those steps in the pattern or that order. However, if leadership remains in the public eye, then these preparations indicate that an exercise is imminent. So that is an example of deductive reasoning. You go from something that's kind of generic, like troops are deployed, to something specific as we're having a conflict, a very public conflict with another country or another group, for example, that you can make some assumptions about what is going to happen. Abductive reasoning reveals possible outcomes. So it's the process of generating the best explanation for a set of observations. When actions might defy accurate interpretation through existing paradigms, this type of reasoning generates novel means of explanation. And in the case of predictions, an abductive process presents an assessment of probabilities. So it's not just going straight to that specific, but here's a number of different probabilities and which might be best. Although abduction provides no guarantee that the analyst has chosen the correct hypothesis, the probative force of the accompanying argument indicates the most likely hypothesis is known and that actionable intelligence is being developed. So you are starting to come up with different possibilities for what an outcome might be. Now moving to spatial awareness. So this again gets into a little bit more of the how we kind of understand space around us. People who are drawn to the discipline of geospatial intelligence, and I say GIS, geospatial technology, have minds accustomed to assembling information into three-dimensional mental schemes. So again, this gets into the kind of space-time continuum that we talked about earlier. We construct schemas in our mind. We rotate them and we view them from many angles. You may not do this on a regular, and if you were thinking about the stop sign example, I know you're probably not thinking about stop signs all the time, but in other examples, we have these schemas in our mind and we try to look at them from different perspectives, or at least hopefully that's what your four-year degree is helping you with, is looking at them from different perspectives and viewing them from different angles. And so the experienced geospatial professional imagines spatial schemas influence in the fourth dimension, which is time. What happens in the future, what has happened in the past, what is the difference between those two things? You throw in current and you have three different elements there. We mentally replay time series of the schema, like what happened in the past, what's happening now, what happens in the future. This becomes just part of kind of a geospatial professional's way of seeing things. Their ability to assemble multi-dimensional models, things from multiple perspectives. This isn't getting into computer programming or modeling, but like literally abstract models that the expert does it with incomplete data. You can start to make some assumptions about looking at making a model without knowing everything. And that goes towards those different examples of reasoning we just talked about. We mentally fill in gaps, making an intuitive leap towards a working schema with barely enough data to perceive even the most rudimentary spatial patterns. Like we think we know what's going to happen next. And this happens with practice. And as you see things in this time-space perspective as a GIS person looking at maps all the time and understanding these patterns and phenomena, that you're going to start to fill in the gaps like, oh, I've seen this before. I know what's happening. It's happened over here. So that it begins to become more of a natural part of the way that you are interacting with the data and with the technology. Expertise increases with experience because as we come across additional schemas, our minds continuously expand to accommodate them. And that is called spatial awareness. So you have started to get a feel for these schemas and these patterns, and you start just to pay attention to those things more naturally as part of your observations of the world. And I say world, but maybe your communities. And so you become more spatially aware. Visual spatial thinking. What is it? It's where you think in pictures rather than words. We're visual creatures. We tend to like to have some sort of visual to help explain whatever it is that we're learning about. Um, we do this in lots of different things, not just GIS, but this idea of visual spatial thinking is where you're thinking in pictures rather than words. And what is a map? It is a picture, it is a visualization. Um, Visual spatial thinkers think in terms of the big picture first before they examine the details. And there are different ways of thinking that you go the opposite way. You think more of the details before you get to the big picture. And that's a different form of thinking. Not better, not worse, but just different. Non-sequential in visual spatial thinking means that thinking and learning do not happen in a step-by-step manner. Non-sequential thinkers arrive at correct solutions without taking steps. They may have difficulty with easy tasks, but show a unique ability with difficult, complex tasks. So that means that the details become a little bit the details preceding the big picture um, may be too much for a visual spatial thinker. They tend to think big picture, big ideas, and then move down into the details later. And you may be working with people that are exact opposite. So that can present its own set of problems, right? And so understanding how we think is really important to this. So systems thinkers are visual spatial thinkers, and they can orchestrate large amounts of information from different domains, social, economic, political, but they often miss the details. Um, and that may be the difference between a manager and a director, for example. They're coming from different perspectives, so they may have different prerogatives as to what they see as the most important and how you get there. Alternately, sequential thinking refers to a person's ability to mentally process and organize information. This sequential thinking, a person with high sequential reasoning skills is able to automatically shuffle and organize large amounts of information. These people can logically add, sort, store, and retrieve information relatively easily. They often don't feel the need to write down ideas, or have their physical surroundings organized in a highly structured way. People with high sequential reasoning often need to explain their thought process to others. I made an error on this slide here, but they like to make visible plans, schedules, and explanations for others. They want to make sure that these details are transparent and that you understand that you're going through this process. They often write very clear, logical communications. And sequential reasoning is more about planning and less about execution, which can be debatable, though. I mean, you're planning to do something. And so um, I may disagree here about the difference or the importance of non-sequential and sequential thinking for this reason. But typically, like how it may present itself is that sequential reasoning is more about planning what are the steps to getting this done instead of I'm going to be the one that actually does it. And that may be the non-sequential thinker that ends up doing it. What does this have to do with GIS? So, we're talking about thinking, right? We're talking about abstract concepts as it relates to the way we identify with geographic information. And depending on your style of reasoning, you may be more suited to certain GIS tasks. When we were doing a review of the GIS&T body of knowledge, you saw those different domains, and I pointed out the ones we were going to be focusing on in the introductory class versus somebody with a 4-year GIS degree. But you may find that as we're learning GIS and as we're talking about these different GIS aspects and roles, that you may find yourself suited to a certain kind of position or a certain type of role, different from something else. So that's why I think it's important to point this out, is that you can have a lot of different interests. You can focus on one or two things as it relates to GIS, and how to apply that to what it is that you're working on. But depending on your style of reasoning, you may be more suited to digitizing, creating spatial information rather than creating the query that goes to pull data out of a data set. You may be more interested in taking historic maps and matching that up with current maps, rather than I'm going to build this GIS inventory of the city of Cleveland that has lots of moving parts to it. So that's why. Are you more apt to collect and manage large data sets? Are you more apt to organize and explain the GIS processes? Are you more apt to prepare the analytical process needed to provide an end result? All styles of thinking lend themselves to an aspect of GIS. And the question is, which will your strengths be and how will you use that? And so I think that's the last slide here. It is. So for this, I have a reading for you. It is about spatial thinking. Sorry about my dog there. There's somebody walking out the window, in front of the window. But I ask you to read the article, and there is an example, an experiment that's listed in there. That's annoying. I'm sorry, guys. And I ask some questions that are taken directly from the article. So you don't have to guess. All of the information related to the questions that I ask are within the actual article. As you respond to the questions, I want you to think in terms of complete sentences, maybe some extra details. It doesn't have to be a book, but maybe a couple sentences. And feel free to add more that you'd like to add in your response. I never penalize for writing too much or writing a lot. It's not writing so much that gives me problems, because I can't see your wheels turning. I can't see your the way that you're going about the response. And I need to feel confident that you understand what it is that you just responded to and you're using the vocabulary correctly. Some of the terms may be new to you. You may have to look things up. I think I did a pretty good job of an overview in the PowerPoint, but it's not exhaustive. It's just introducing the idea, and the article provides you with a little bit more detail in terms of some of the science behind it. So I'm going to stop the recording now, and I look forward to talking to you about the next topic soon.